Hi, thanks for joining us. My name's John Eichman. I'm the Director of Marketing here at Optimal Dynamics, and I've got a group together today to talk about challenges of building something and building a solution in logistics, right? And before we get into the topic, before we dive in, I'd like to go around the horn, let everybody introduce themselves so that you know who you're talking to.
Hi, I'm Warren Powell. I'm the Chief Analytics Officer at Optimal Dynamics, also Professor Emeritus at Princeton University, where I taught for 39 years. This is how I got started with this field, working on trucking and freight logistics problems, which brought me into the general area of making decisions under uncertainty.
Hi, I'm Josephine Nord. I'm the Director of Product Management here at Optimal Dynamics, and I lead our product management team.
Hi, I'm Christina Carter. I'm an engineering manager here at Optimal Dynamics, and I lead our strategic platform team.
Hey, good afternoon. I'm Joe Wagner. I'm an engineering manager here at Optimal Dynamics, and I lead our integrations team.
Hello, I'm Scott Gowan, Senior Director of Value Engineering, and I support our solutions engineering team.
Thank you, everybody, for taking the time out of your schedule to come here and join us for this conversation. So again, everybody, the topic is the challenges that come from the logistics industry and building a solution in it that are, unique to this industry. And so to get us started, I think it seems only right that Warren, you're the most senior on the team. You've got the most experience in the industry. Why don't you tell me what you think some of the challenges of building in logistics are?
So one of my favorite topics is understanding the impact of uncertainty on logistics. You can't talk about logistics without dealing with uncertainty because this is a very dynamic field. You've got customers in the marketplace creating demands, but then you've got the production problems, you've got weather problems, you've got equipment problems, you've got people problems, you've got political problems, you've got regulatory problems. Now, in the world of truckload trucking, it seems a little bit simpler because we're dealing with what loads the shipper is going to give you. Is the driver going to accept the load? Do we have an equipment problem? Do we have weather problems? Do we have delays with how long it takes to load or unload a truck? And so in the world of trucking, these are the immediate sources of uncertainty. In the broader world of logistics, we open up an entire Pandora's box of different types of uncertainty. Think of the Fukushima disaster and the ship getting stuck in the Suez Canal. But let me target it down on truckload trucking. One of my favorite topics and the topic of optimal dynamics. When I take my career back to the 1980s and 90s, one of our big breakthroughs as a community was how to optimize airlines for next year. And it's a schedule and it's deterministic. And we have this great theory. And I remember a friend of mine in General Motors Logistics complaining, the airlines have this great theory of integer programming, which is called. We don't have anything in logistics. And the reason is because of uncertainty. If you take a toy problem, it's hard to do it in logistics. Let me do something with buying or holding or selling an asset. So you have three things you can do. And after that, the price goes up or down by three. And then you have three more things you can do, and so on and so forth. You look a few time periods out, and you're quickly in the tens of thousands to millions to billions of possibilities. Now take an entire truck fleet. We have all the permutations, combinations of signing drivers to loads, and then you've got the uncertainties of shippers calling in loads, drivers wanting to get home or not wanting to take a particular load, weather delays, that type of thing. So I spent pretty much my career dealing with how do you handle freight transportation? How do you deal with uncertainty? And originally it did come from a truckload carrier, Schneider National. Schneider had models. They were all deterministic, and they would plan out 7 days, and they would plan as if they knew what was going to happen for the next 7 days. And a manager at Schneider National had dinner with me in 1982 and said, Warren, the world is, and the world he used because he has training in operations research, he says, it's stochastic. What do we do? And I found myself listening to that and going, wow, what a great question. I not only don't know the answer, I don't know how to think about it. And it took me roughly a career. It was the early 2000s that several decades of thinking started to come together. And I had developed some powerful tools. And we then got a call from Schneider National to apply it to Schneider. They wanted to optimize the fleet. And we had to handle simulating dispatching drivers and handling uncertainty. By the way, they were throwing in the twist that they wanted to plan 7 days out and track every individual driver. And here was the really neat thing. When you try to optimize over 7 days, you've got to simplify in some way. You cannot handle a high level detail. But when you have uncertainty, you never optimize out over 7 days. You're always going to roll out, but then you have to approximate the impact of a decision now in the future. So what we did is, instead of solving one very large problem, we ended up solving sequences of much smaller problems. And a really neat byproduct of that was that now we could actually simulate every individual driver. So one of the breakthroughs we got by handling uncertainty, which was, instead of solving monster problems, you solve sequences of smaller problems, we suddenly could do it at a much higher level of detail. So this was our breakthrough, called approximate dynamic programming. And it was allowed us to simulate this big fleet of drivers, or to use the same technology in real time to dispatch drivers now using an approximation of the impact of drivers in the future. What's the value of a Texas-based driver in Massachusetts on Wednesday? So we got that technology down, and that was great. But then I kept climbing the ladder. I was able to get one of my star students to return to the lab. And I said, Juliana, we've got to do load acceptance. We've got a lot of problems in truckload trucking where the shippers will call in a load 5, 6, 7 days in advance, and we have to say yes or no now. I don't know where my drivers are 5 or 6 days out. I don't know where they are 3 or 4 days out. So we built a model that would simulate our way 7, 10 days into the future, and we would do it 20 times. So we would have 20 sample realizations of what might happen in the future. And then we could take a look at every load in the system that had been offered and say, did we cover the load? And out of the 20 scenarios, we have some loads that we cover them 20 out of 20 times. We have some loads that are just in the wrong place. We can't cover them at all. And then there's a lot of loads where we can cover them 18 out of 20 times, 15 out of 20 times, 10 out of 20 times. And for that, what we can do is take a, pick a point and says, okay, what do I want to do? Do I want to be 80% confident? Do I want to be 60% confident? Say yes to that. And then those loads that hit that standard, we will say, okay, let's bring them into the system. And now we have our base loads plus these additional loads. And now as I optimize, I can choose among these additional loads that it looks like I can cover, because I have a pretty good idea that I might have a driver, although I don't know which driver. I don't need to know which driver. I just need to know that I have enough drivers in there to shuffle around. Now, one of the powers of these modern optimization systems is we optimize over all the drivers all at the same time. Now, if you've got 10 trucks, you're going to have a tough time in this industry. But as you have larger and larger fleets, you can do a lot of shuffling. So let's say a load pops up and I don't have a plan for it, but I can re-optimize across all the loads and all the drivers and shuffle around a driver, maybe pull a driver off of a lower priority load, get into a higher priority load. But when you optimize across all the drivers, this allows your entire fleet to work together. So one of our biggest problems is, you've got a region, you've got 5 drivers up there and a handful of loads, but certain drivers want to go to Florida and somebody else wants to go back to New Jersey and somebody wants to go to Texas. I don't always have a lot of choices. However, if I've got 5 drivers in a region, but my whole fleet has, I don't know, pick a number, 500 trucks, I actually can use all 500 drivers to shuffle around and match that driver. So this is the big power of truckload fleets in handling uncertainty, because if I have a hiccup, the driver doesn't want to do it. This driver took too long to get unloaded at that warehouse and couldn't arrive on time. As long as I have a big enough fleet, I can always look around and grab some other driver. Now, I need to plan for this. I need to think about the future, but this is something where by using the whole fleet and letting the whole fleet work together, you can actually do quite a bit to mitigate the effects of uncertainty. So what we've done is we've developed sort of a new way of thinking. And that new way of thinking involves starting with uncertainty, realizing that you have to plan around uncertainty, even when you're planning in the future. So what you don't want to do is to say, oh, I'm planning for the future. It means I have to forecast the future. I have to know exactly what I'm going to do in the future. It's just not true. What you have to do is to set things up so that you're positioned. There's an industry called finance. You go into Wall Street, they don't know how to not deal with uncertainty. Wall Street exists for uncertainty. It's the only reason for going there. For some reason, there's this idea in business that if you forecast and plan into the future, you've got to predict what's going to happen. Just not true. If you told somebody on Wall Street that that was going to be the case, they'd laugh at you. Logistics needs to really internalize this, I'll call it the stochastic way of thinking, this planning where uncertainty is always there. We can do things to mitigate uncertainty. It's never going to go away. Anybody in logistics understands uncertainty never goes away. We have to live with it. You just have to deal with the right tools and the right way of thinking.
You bring up a good point about the supply chain and the complexity. I think when I look back at my career, started off working for carriers. I worked for 3PLs. I worked for shippers. I worked on the technology side. If you look at the whole supply chain, or look at the supply chain as a whole, you've got inbound raw materials coming into the ports. We've got to deal with drayage off the ports. We've got to get it to our distribution centers or plants. We've got to then get it to our customers. There's just a lot of moving parts when you talk supply chain, and trying to manage that can be very hectic and complex.
So speaking of that complexity, it's probably one of the biggest challenges from an engineering perspective as well. Working with this AI engine is complex, and it's the job of engineering to communicate with the engine and delivering customer solutions provided by the engine. So as you know, we are basically the layer that is between the engine and the customer. So we need to understand what the engine needs as input, and also what the engine provides as output. And really how to display these complex recommendations in a way that is usable to the user. And you know, we also have to be prepared to take response from the customer. So if the customer declines a recommendation, we need to take that input and feed it back into the engine. So it's a complex task, and it's something that we're constantly having to work through and improve.
Yeah, that's an excellent point, Christina. I'd actually love to jump in here next. From the integrations end, you know, one of the biggest challenges we find is determining which systems to integrate with. Data really drives every decision that we make here at Optimal Dynamics, and the data just never lives in just one system. From our past experience, we see multiple systems in play all the time: TMSs, ERPs, ELD providers, load boards. And our customers ask us to integrate with each one of these systems. And we really need to determine, is this the right system to integrate with? Does this contain a piece of the data puzzle that is going to lead us to our end goal, which is really creating a digital twin of our carrier or a shipper's network? Moving forward, when we're building these integrations between systems, we really need to make sure that they're in real time. For example, OD has a dispatching module. We're going to recommend what driver to take on which load. Now, we might recommend driver Jay Wagner take load 1, 2, 3, but driver Jay Wagner does not want to take this load and declines this assignment. What happens next? We need to have another driver ready to be assigned to this load. Optimal Dynamics can't wait 3 minutes. They can't wait 5 minutes, maybe not even 2 minutes. We need to make a decision immediately. And so that's really where these direct integrations with our transportation management system partners come into play, and also how our engine produces our recommendations. We have something in our dispatching module called ranked order dispatching. We're not just going to give you the top driver for this load. We're going to give you the second best driver, the third best driver, fourth best driver for this load. And then, you know, I think about challenges, a ton come to mind, but just the complexity of data and the sheer amount of data that we receive from our customers is probably number 2. Our team spends a great deal of time finding information within this data and redoing data analysis over and over and over to make sure that we, 1, understand this data, and 2, that we can fully utilize it. So with every new customer comes new technology that comes across our desks, and we really need to sit down, do some discovery and due diligence on these new technologies and ensure, is this something that we should go out and build a scalable direct integration with? Or is this going to be a one-off, and maybe we wait a little bit before we decide to invest and build an integration? You know, we're always seeking new partners and new partnerships, and I really think that's essential to delivering a world-class product to our customers.
Actually, to piggyback off of that, Joe, speaking of one-offs, we kind of have a similar thing on the engineering side where we have to decide when a certain customer has a request. whether or not we fulfill that request, because everything we do needs to really kind of be reusable while we're building a SaaS platform. So what can we do? How can we take individual requests from customers and turn it into something that can be used by all customers?
Those are some great insights, Joe, Christina. Thank you. Josephine, I don't think we've heard from you yet.
Yeah, I was going to say, one of the complexities that we see on the product side, speaking of one-offs, Christina, is that there's a lot of nuances and specifics, idiosyncrasies that each of our customers has within their data. So there's a matter of getting the data and making sure that we can process it appropriately. But then there's the effort that it takes here to understand all of the tribal knowledge that goes along with that data as well. So there are shortcuts and hacks that our customers use to use the systems that they have. Some of them are legacy systems without a lot of flexibility, and they use specific types of data essentially as placeholders to allow their dispatchers, allow their load planners to know something about the load or something about the driver, something that we wouldn't know until we get through that design and discovery phase with our customers during onboarding. For example, our customers have a specific way of dealing with appointments that don't have set times yet. So maybe they know the appointment generally will be on Tuesday, but the customer hasn't confirmed whether or not it's going to be, from 12 to 3 or from 3 to 5. So they use 11:11 or 12:12 to specify, hey, this appointment is unset. That allows them to just quickly have a visual indicator, essentially saying, like, this is an unset appointment. I know that this is going to change. For us, we take the data as it is. So unless the customer gives us a heads up or we notice that during onboarding, it's not something that we could just pick up on. So during the discovery and design process and our conversations with customers, that's when we really start to work with them and uncover all of this tribal knowledge. When you're talking about supply chain and logistics, yes, it's talking about, the lack of trailers and the lack of trucks and all of the shortages, but we're also talking about people. Drivers are people, dispatchers are people, load planners are people, and people have preferences. Driver retention is a huge issue in the business right now, and allowing our customers to accommodate specific driver requests and driver preferences. They will not drive to the 5 boroughs. They will not drive through downtown Chicago. They will not go to Minnesota in the winter. That's especially important for us. And it's the flexibility on the product side that we're looking to incorporate, not so much as one-off requests for a driver or one-off requests for a customer of ours, but incorporate all of this flexibility so that we can take these into account when we're making recommendations on the engine as well.
I agree with what Josephine said. I think it's really important and vital to a successful implementation is putting emphasis on the design and discovery session with our customers. And really making sure that the right people are in the room for these meetings. We can't just have the technical folks that understand the data. We also need to have the business folks and operational teams that are going to be using our platform, really those end users, to help us fully understand their data. And when Josephine mentioned the 11:11 or 12:12 unscheduled appointment times, that resonated with me really well. We actually just had a customer recently that was sending us movement data with appointment times 70 years in the past for the pickup, and the delivery window about 20 to 30 years in the future. Looking at these movements from the outside, it appears these appointments were possibly never scheduled, or maybe a planner or dispatcher fat fingered the wrong year on the movement. But through our design and discovery sessions with our customer, we find out these appointment dates are actually used internally to indicate to an internal planner that this is an empty move. So without one or possibly multiple design and discovery sessions with our customers, we might have removed this movement from our platform due to bad data, whereas really this was just community knowledge or tribal knowledge within this customer.
Yeah, I think that tribal knowledge is a really good point for this discussion. And it kind of gets me thinking again just about the people that are in logistics, and the importance of the people in these operations, more so than other industries. Like, there are so many unique different types of roles and different types of jobs that are all just critically essential to this chain. And that brings up a suite of its own unique challenges that there's a plenty to dive into there. We're running a little bit low on time here though. So before we have to close out this webinar, just Scott, would you maybe elaborate on that a little bit more on some of these things?
Yeah, thinking about additional challenges that as far as this process goes, I think one that really comes to mind is change management. We often sell to the executive team, and there's good buy-in there, and then it filters down to generally to the operations of the people on the floor. And so when it comes down to the people that are actually using our tools, using our platforms, those are the people that we need to connect with, make sure that they understand what they're doing, that they understand the value that it can bring to them. I think one of the things that we run into, though, or that we'll likely run into, is that people are going to defend their turf. They're going to think we're trying to eliminate their job. And really, it's the opposite of that. We want to make their job easier. We also want to free up time for them. If you look at one of our main solutions is real-time dispatching, and that's going to deal with the dispatchers at the ground level for all the carriers. And I know, having worked as a dispatcher, even it was years ago, you spend a lot of time just trying to figure out how you're going to get through your day, making sure your loads are covered. A lot of times, though, you need to talk to the drivers. They need someone to complain to. They need someone to either get more information from, someone to just talk to them because they're out on the road all the time. And I think one of the things that that we can do is help them through that change management, help them recognize that we're going to make their job hopefully a little bit easier, give them some more time to actually deal with the exceptions instead of dealing with just the day-to-day decisions of which driver to which load, but focus more on the relationship piece of the puzzle. And I think that ties back to a couple of things we've said about driver retention being a huge issue in today's industry. And anything we can do to help our carriers keep their drivers, reduce turnover, and in this case, make the job easier for the dispatchers on the ground level, I think is necessary and critical.
All right, thanks, Scott. It's a really good answer and the perfect way to wrap us up. That's all the time we have for today, everybody. And I hope you really enjoyed this conversation. We wanted to get down into, really a different kind of content than we've done before, and really give you some insights into the ways we think and some of the problems that we've encountered as we've developed this solution. If you want to learn anything else about optimal dynamics, or you really want to see more content like this, you can follow us on LinkedIn. We always post all of our content there. We've got a really robust YouTube channel where we put all of our video content. And of course, you can check out our website, or, the old-fashioned way, just feel free to give us a call. You can reach out to us. We're more than happy to give you a demo, walk you through the platform, and explain anything that you want to see. But until then, we'll catch you next month on the next webinar. And thanks for coming.
Bye.